see Mike's technique. He's holding it against the fence. It's intrude, he engages, and he goes through it. There's the Lexan guard, so if there's a chance the laminate will cut, whatever your plant policy is, watch those first edges. We just see there's a Lexan guard here, so the gloves are the problem. Alright, we're going to take the top off so you can see it inside too. Here's what's doing the work inside, just so you know. And this is the new configuration. I think Mike, probably discussed with you, which has a rigid coupling here that allows us to disconnect from the drive or the chains so that the blade changing is a little less onerous. The height of these fingers off the table down here, when you keep the laminate from riding up, is very critical, which is why you have this locating pin running all the way through. Okay, here's your last piece, guys. Not sure what I can videotape that you want to see the most, but I think you've pretty much seen all the key elements now. MLS 12 model V2.0. The gentleman that will be doing this today is Mr. Mike Ray, and we'll proceed with the basic steps. Show the blade removal for either sharpening or configuration, reconfiguration. The tools that we need for this, Mike, could you describe them for me real quick, going down the line there, left to right?
9/16 wrench, 7 32nd Allen, 1/8 inch Allen, 3/8 Allen, and a 9/16 socket with a minimum of a 10-inch extension.
And a pair of gloves.
And a pair of gloves.
All right. And we're going to start on the machine by first of all making sure that the electric supply has been disconnected. This is important, or normal tag-out procedures in your plant, whatever is required to make sure that there's no power to this machine while it's being worked on. Okay, Mike, go for it, and feel free to comment as you go.
First thing, we'll remove these covers.
Okay, you have those in there loose for purpose of the film, but what tool would they use to take those off?
7/16 wrench.
All right, your 7/16 wrench would remove those. You're obviously going to need a table nearby to put your parts on. You're also going to need it for your shafts, and you need to have a way to hold your shafts once they're out too, your arbors, to make sure that they're not damaged. You're removing the dust cover on the chute. Same size screws, Mike?
Same size. 7/16 wrench.
We're now using
3/8 Allen, and if you'll notice that you can...
What we're doing is we're turning the shaft, right? Turning the arbor to get the coupling up at the top. This is the new feature of the version 2.0 in the MLS 12. It's basically a method of removing the arbors without involving the drive, the chains, so that it will make it quicker and easier to do.
Okay, with it, they're both right-handed threads, and once you have rolled the shaft to allow that coupling to come out freely where the male is straight up and down, and you can loosen your bolt. You want to loosen it now because it's a lot easier to do it now than trying to wrestle with it when you have it out of the machine.
Right, sort of undoing the lug nuts on a tire before you jack it off the ground.
You do it in reverse process of when you put it back together. You want to.
Unlike earlier versions, both are right-hand or clockwise threads, so in the old days we had one way and one the other way.
Top shaft, all we have to do is take the 4
Is that the
bolts loose,
9/16?
9/16 wrench. Sometimes it's better to use a wrench on this one. They're easily accessible. and then remove the top shaft and you lift straight up.
Okay.
Now that you can hold your shaft down so your hands will be free.
And there's no problem, what you're putting on the vise isn't going to score the shaft or anything because you're in the actual joint
it's
section,
protected.
right?
Yeah.
Okay, everybody see that? Want to make sure you understand what's being put in the vise, okay?
Remove this retaining bolt.
This, by the way, is the take-up spacer. It varies depending on the configuration here as far as what size that is or how many individual pieces it takes to make that up.
When you remove your spacers, it's best to label all your spacers with the numbers. It's just for a resharp, and then renumber them with the configurations you change so you can return them back in the same locations. When you remove them, it's best to take the spacer to allow it to slide the blade off up and down, and that holds it true to the shaft.
If the machine has been used a while and it's dirty in the plant, the shafts are dirty, you got any recommendations, Mike, on what should be done as far as cleaning the shafts up to make it easier to remove them? Are there any tricks you've learned over
The best
years?
thing is air, to blow them off clean, and if the material has stuck to them, then you want to use a solvent of some type.
Okay.
It can be a harsh solvent. These metals will withstand lacquers, thinners, acetones, whatever you have to clean them with. But then, when you go back with them, you need to oil them with them clean.
You're talking about oiling them and putting them back on. You're not just going to do that, correct? Is there anything we need to mention yet about what you would be doing different if this was not for taking them off for sharpening, but for reconfiguring?
All right, well, you with your configurations of whatever blade gaps you want, your base retainer stays on the shaft. It doesn't move. So whatever gap you want, you start from that location and you set all your top shafts in accordingly.
Right, now the top shaft should be for the exact width of the cut. For example, if I wanted a 1-inch cut, I would have a 1-inch spacer between my permanent spacer here and the first blade, correct?
That's right.
And I wanted a 1-inch here, it'd be the same thing. If I wanted a 1 1/8, then I'd have an 1 1/8 of spacers on the top shaft, correct?
That's correct.
Now when we do the bottom shaft, each one of these would all be 1/8 of an inch less. Is that correct?
No, a 1/4 of an inch.
Quarter of an inch, I'm sorry.
On your first cut, it will be 1/8 of an inch.
Different,
Then,
okay.
Right, and then narrower than your top, and then every other one will be a 1/4 of an inch less to allow for the 2/8 inch bottom blades.
Okay, so in effect, if I wanted to go to a 1-inch, I would have a 1-inch spacer on top here, on the first cut in from the fence being over here. On the bottom shaft, this spacer would be 7/8, correct?
That's correct.
Here it would be 3/4 on the
is
bottom
correct.
shaft, right? Even though
Yep.
it's 1 inch on the top shaft,
Yep.
correct?
That is correct.
Okay, very good. Gentlemen, you want to put that rule in your pocket because it's easy to remember.
Now when you're just a resharp, when you return this blade, the bearing, I'm sorry, everything will remain the same. If you change the configuration and you change this take-up, then you need to loosen these set screws in this bearing right here
Okay.
to allow this particular bearing to float on the end of the shaft. This one does not change, this one will. Allow it to float to take that up, and after you've tightened it down in the machine and everything's aligned back together between the bottom blades, then you will tighten them 2 set screws.
And they're raised, okay.
And what I'll do is, for this particular case, I will loosen these up. So when we put it back in the machine, you'll see.
You're going to show them the worst case. They won't normally have to do this unless they change the configuration, but if they watch the tape, they'll be reminded what they have to do. I got you.
And then this allows the bearing to float, so it can, if this distance in here changes, it'll allow this bearing to float.
To where it needs to be to line up on the bolt holes.
Correct.
Okay, very quickly, we're now going to remove the bottom shaft and understand if the configuration isn't going to change, then basically these won't have to be moved except out of the way, but you won't have to shift them back and forth. We'll talk about it when we put it back in, what you would do for a different blade configuration. One thing you're going to be doing here shortly is you will be cranking the bottom shaft around to have it in the same orientation as the top so that the piece can be dropped out. Okay, go ahead, Michael. Using the 1/8 inch Allen, correct?
Yeah. What we'll do here is we're going to take off the finger bar.
Okay.
Or the
retaining bar.
Yeah, and take all the
retainers out.
The spacers out of it to allow the bottom.
How many we got of those? About 4 on the side? 3 on the side?
3. Only 3 on that side.
Here we got our 3 or 4, was it? 3? Okay, removed on the retaining bar. The space retaining bar, the main spacers coming out. Now Mike's just going to slide the rest of these out. Obviously, if you were changing the configuration, you'd relocate those under the fingers at the new widths. Yeah, they'd be centered over the new widths. 9/16 again.
Yep. And here's where the extension comes in. You're going to loosen the bolt. Same thing as the top shaft. The bottom shaft is offset to accommodate these bolts. Need a 9/16 wrench up here on the front bearing. Same thing, 2 retaining bolts. And remember, you want this loose before you take it out of the machine.
Loose meaning the cap screw at the end of the shaft.
Correct.
Mike's removing the 2 back bolts. Okay.
It's better to use 2 people if you have them available, but you can do it with 1.
So one more time, we're putting the rigid drive end in the vise so we don't worry about scoring anything that matters.
There again, if you change your configuration, unless you change your configuration, you don't need to worry about changing the hub. It'll stay in the same location. If you change your configuration, then you need to loosen the set screws.
In other words, if you're going to use a different take-up spacer than the one that's there when you remove it. And one more time as a reminder, this is where you're going to be off 1/8 inch and then 1/4 inch thereafter. So these would all be 3/4 on a 1 inch cut. This would be a 7/8 spacer.
Okay, now when you turn these, it's a little bit different configuration. You have the bottom blade, and you can use your spacers to help align them and get them back on. A 1/16 spacer goes between every set of blades.
That's to maintain the gap that the top one fits in.
Then you put your extractor blade in.
And notice that fits over that spacer, not adjacent to it.
And your
other 1/8 inch blade.
Other 1/8 inch blade. And your when you get to the end, you take up your makeup. And then if you change your configuration, then you want to make sure this is loose. Always make sure that your final take-up is slightly longer than the shaft itself. So that's what retains your blades, holds them together with the torque of that hub.
The final take-up is longer than the shaft itself?
Yes, it has to be. It has to be higher than the shaft. If that right there will not work. Where that the take-up is lower, when you put your final take-up back on, whatever it's going to be, after you've changed your configurations, this has got to be slightly longer.
You want to be longer than the shoulder on the
Correct.
shaft. Okay, come away from them. Now you're going to snug that up, but you're going to have to finish tightening it once you get it on the machine, right?
That's
and then you
correct.
also do the same thing with the set screws if there's been a configuration change.
That's correct.
I wanted to address one thing that's very important here. A lot of this is sort of common sense. This may or may not be to you. This is the finger arrangement on the machine. One of the things we've learned over the years in working with this is the alignment and the setting of these fingers in relation to the laminate coming through is extremely critical. It's almost something that's not to be a user adjustable type item. You can do it if you really feel clever, but you're better off, believe me, if you can leave it alone. So that's why we have an alignment pin besides the actual bar that the fingers actually rest in. Okay, if these need to be changed, you use a 7/64 Allen wrench. The idea would be when you have one of these machines, you buy enough fingers to cover the maximum number of cuts you anticipate ever doing on the machine. In other words, if you think you may do 10 sometime, but right now you're going to use 8, then you want to have us put 10 of these on your machine. And then treat them as coat hangers. When you're not using those extra 2 cuts, for example, between 8 and 10, you would loosen these, slide them here out of the way. They won't interfere with the operation, but you won't have to mess with your alignment and get them off. Okay, the next step is that the fingers themselves would be adjusted obviously with that 7/64 wrench every time you came up with new widths, so these were in the right place. You do that by loosening the set screw, sliding along the keyway, and then just snugging it down again. These should be about a 1/16 difference in width, smaller in width than the actual cut. So if you're anticipating several different cuts, you're going to want different spacers here to fit down in between, and also of course they'd be centered in the cut too, just like the top fingers would be. The idea is then that the piece will be ready to go and you will have less hassle with your laminate traveling through at high speed in this machine with all the cuts. Do your very best to not mess with these 2 pieces here, the alignment pin and the travel bar, okay? You can move the fingers back and forth, order as many fingers as you anticipate ever making cuts for so you can put them on the machine at the factory, because that's a very critical clearance that you have back here on this heel in relation to the table. And the other item is, Mike, these are 1/16 inch less per cut, right?
Yes, sir. 16.
So these should be
to a
15/16 on a 1, between a 1/16 and a 1/4 of an inch is the maximum range that this can be smaller than the actual cut you're making, and they need to be centered in the retaining slot. We're getting ready to put the bottom shaft in. You want to basically get down on your knees here and look at your shaft at the other end, check the configuration so that when you feed the shaft in, you're in roughly that orientation. The next item is that you want to make sure as you're putting the lower shaft in that you're not banging your extractors, which are the clear out rings on your shaft from banging on this. These are them on your machine. They're very loose. They fit like pistons rings in there.
There again, if possible, you want to use 2 people to put this shaft in, but you can do it with 1.
Your machine is orient proof, so you can't put it in backwards. You can't, put the pillow blocks in the wrong settings. They're all set. Everything lines up tight. If you get it in, it will be lined up because of the markers, the location pins on each side. I'm going to end up putting these
Bolt falls down the chute.
bolts, and if you drop it, as Mike just pointed out, it goes right into the chute. If you have this mechanical finger, when you're putting it in, it does go in easier. Otherwise, even though you can get your hand in there, it is a little bit of a trip to drop it exactly right. It takes 2 or 3 tries to get it in there.
Before you tighten your shaft down, you want to make sure that both bearing fits are down in the sets.
Right.
If they're
Make
caught,
sure this is located in here tight, flush with the
front
bottom.
and back, yes. If they're not,
Front and back.
you can break the casting by torquing it down and it being crooked. You want to make sure that it's down in the set.
All right. Don't tie
You
the
don't
front,
want to tighten the front one down if you have changed the orientation.
the configuration, you mean, of the blades?
I'm sorry, yes, the configuration. That
All
way,
right.
when you get your top shaft back in, and then you've tightened everything down, then you can tighten it down after the shaft is seated,
Gotcha.
and then it's in a relaxed position. Start the bolts.
Now returning the fingers. Fingers definitely have two different sides to them. It's pretty obvious which one goes where. This one has got room for the retaining bars, whereas this side doesn't. It just slides in.
You want to make sure that you take up all this space in here, and you can use smaller pieces or what have you if you have extra pieces, but you need to take up that space. Don't leave a void in there where the material can drag or catch.
Okay.
Just return this bar. Pop down there.
We're once more, just like the bottom shaft, we're looking at our orientation so we know which way we want to drop the shaft in. Now, if we had changed the configuration, the bottom blades would have been changed. We would have slid the fingers to the new locations. We would have made sure that the spacers here are between a 1/16 and a 1/4 inch less than the cutting width of the new thing. For example, if we had changed this one to 1 inch, this would be centered by moving the set screw, and this piece here would be anywhere between 15/16 and 3/4 of an inch wide. Okay, and now Mike, having looked at the orientation, is getting ready to drop the blades back in.
You'll be able to see quickly if you've had a problem, because it'll be a severe misalignment.
Another thing there, Mike, is if they have done a change in the configuration, in case they got confused on the 1/8 inch and 1/4, it would make sense to, after they've put their two shafts together, but before they're putting them in the machine, to sort of maybe roll them up against each other and make sure they look like they're fitting right. I mean, if you see that the groove in the bottom blades is a 1/4 inch off from the top blade, you know that there's something you need to check out.
That's true.
You just line these things up, you make sure they're flush. Again, we don't want to break the casting when we lock her down. Check in the back, we got a nice fit in our joint.
When you're dropping it down, rock it back a little bit if it doesn't fall in initially. The sharper blades won't fall in.
In other words, they'll dig in a little bit into the top blade kind of idea.
Yeah, they won't go together as easily as blades that have been run a little while. Once they've run a little while, they'll go together easier.
And if the pillow blocks are flush in their settings, that means your blades have fit and they're snug all the way across, right? Is there any other checking you have to do to make sure all the blades have nested in between the two bottom blades?
Well, it's easy to see, and if you're looking from the end, you can see where they've meshed. If you check both ends, the center ones have to have meshed.
Okay. Because otherwise the blocks couldn't, if both blocks are
Down,
sitting in
right.
their position, you know that it has to have meshed, right?
Yes, sir. Make sure these are tight. Now we're going to tighten up our front hub. We've tightened our bearing, and now we want
So everything's been snugged down, top and bottom, both sets, 4 bearings, 8 bolts.
And now if you've changed the configuration to where you need a realignment here, and you want to tighten up your set screws.
And that's on the top and bottom shafts, both ends, right?
Yep. No, not
at
this
the
end
back
will never
end.
move. That end will not
Okay,
move.
that end never moves.
If that end moves, and
You're in trouble, right?
yeah, there's no reason for it to move.
So remember that, you guys should probably know it for sure, but don't undo the set screws in the races on the chain end of the machine on the drive end.
And if you have not changed your blade settings, then
these bearings won't, the distance won't move, so you don't have to loosen these set screws.
But you would tighten that cap screw and then you would tighten the set screws, correct?
That's correct. Yes, it is.
Before you put your cover back on, you want to make sure that all your tools have been gathered up, all your pieces in place. Make sure again that you tightened all your bolts down, holding your bearings in place. And if your tools are clear, you're ready to put the top on. If we had our druthers, when this machine left the factory, we would take those knobs off or weld them in their current positions. This fence is not intended to be moved. It is aligned at the factory. It's a factory alignment. There's no reason under any kind of circumstances other than this thing being run over by a forklift where that fence should have to be moved. However, if someone feels they have to move that fence because it isn't aligned or square with the first set of blades, Mike's going to go through the procedure he uses to align that fence up before he leaves it alone. All right, Mike, go ahead.
Without using an elaborate situation, using tools that you will have in your shop, you need a good scale, 24-inch preferably, but the intent is to get it square with the top blade by rocking it back and forth until you get a good, solid, firm fit against the blade.
And it's the top blade, not the bottom blade.
That is correct.
The top blade is where the laminate goes, not the bottom blades.
Okay, then you want to measure the opposing ends. The fence hinges here, so this dimension when you're changing on the other end will not change as you move it. So you should take your first reading from this side. Then you want the other reading on the other side to match it within the 64th of an inch or less.
Now when you're measuring, Mike, are you measuring inside the slot on the fence strips?
Inside the slot of the fence strips to the scale.
Okay.
And then when you move to the other side, then you measure, and you want it to be within a 64th or less. No more. Then you make your adjustment here, and it hinges in that location, moves here, and then this knob is tightened to secure it within that dimension.
You notice that even now Mike, to show you, is not letting that knob loose from where it already is. And if you have to be a 64th out on one or the other, probably on the outfeed side, correct, Mike, so it doesn't pinch the laminate?
That is correct.
There's a bolt back here on the outfeed side. This is the hinge for the entire fence. And this knob and this scale are what are used to move on that hinge. And it would be a very good idea. I think it's also ball-peened on this, isn't it, Mike?
Yes, it is.
Okay, the original alignment is ball-peened on this scale. I don't know how well it shows up in the camera, but there's a punch on there right now showing that it's lined up with this center mark here. So if for some reason it's inadvertently moved, you know where it should go back to, but again, double check it with the rule. Plug it in and rock and roll.